recording. And today we are going to start chapter 8. Chapter 8 is about mathematics in finance. And did you make me present? Yes, Emma, I did. I saw your name in the list. The first section, 8.1, is about percent and its application in finance. Hi, Angie. Okay, so let me spend a little time to update. In the future, please try to get on the meeting a little bit early. So what I'm talking about, so the first section of chapter 8 is about percent and its application in finance. All right, percent. Per here means divided by. Cent means 100. Okay, let me get my note. Percent. PER in mathematics means divided by. Cent. How many cents in a dollar? There are 100 cents in $1, right? How many years in a century? Century. We also know there are 100 years in century. So cent, C-E-N-T, represents 100. Percent means divided by 100. Percent means divided by 100. Whenever the word percent appears, it always have a number in front of it. We always say 40%, right? This is the percent sign. 40% or 35% or 99%. Without the number in front of percent, this word is meaningless. There's a difference between percent and percentage. There's a difference between percent and a percentage. When we talk about percentage, we don't have to specify the number. We can just say, what's the percentage of the students passing the class, right? What's the percentage? Well, what's the percentage of the trust of the subjects in the survey that they trust in the government? So when we talk about percentage, we do not need to have a number in front of percentage. But when we talk about percent, it always goes with a number in front of it. 40%, 90%, 100%, right? So that's the difference between the two words. Percent, again, means divided by 100. If we have 20%, 20% means 20 divided by 100. Okay? 20%, 20%. Remember, percent means divided by 100. Simply means 20 divided by 100, and that is 20 over 100. If you use your calculator to use the numerator 20 to divide by the denominator 100, you have 0.2. 0.2 is the equivalent decimal of 20%. 20% as a percentage, it has different forms. We do need to know how to convert a percentage to its equivalent decimal, to its equivalent fraction, and vice versa. For example, convert a decimal to the equivalent percentage, or convert a fraction to its equivalent percentage, right? So that's the first thing we need to cover in this section 8.1. Let's look at the first example. Express the fraction as a percentage. Actually, more accurate, we should say express the fraction as a percentage. So 3 over 8. Let me show you how do we go from fraction to percent. Let me get a scientific calculator. We go from fraction to decimal, and then from decimal to percent. That's the order. All right. In general, if you need to convert a fraction to its equivalent percent, you have to convert a fraction to decimal first. Let me show you. So we are given a fraction 3/8. Use the numerator to divide by denominator. That's a decimal, right? And then multiply the decimal by 100. And then write it down, 37.5. Attach the percent sign. Okay, let me explain again. So we have a fraction 3/8. We firstly convert the fraction to the equivalent decimal. Use 3 to divide by 8. So the decimal is 0.375. All right. Now, how do we go from decimal to percent? Knowing if you attach, this is the percent sign. If you attach the sign to a number, basically you divide that number by 100. Means you make that number 100 times smaller. Let me say it again. Let's say we have a number. When you attach the percent sign behind the number, remember percent means divided by 100. We are actually dividing the number by 100. When we divide the number by 100, we make the number 100 times smaller. To balance that, you have to make the number 100 times bigger. You know what I'm saying? So remember, this is a decimal. That's equivalent to the fraction. Firstly, we make the number 100 times bigger. We multiply the number by 100, or simply we move the decimal point to the right twice. 0.375 multiplied by 100 is 37.5, or simply we could move the decimal point to the right twice. So that is 37.5. We make the number 100 times bigger because we are going to attach the percent sign. Once we attach the percent sign, we have the number 37.5 100 times smaller. So it's balanced out. It's good to understand why we do that. All right. So that's the explanation why we have this process to convert a fraction to decimal. And actually, when you do it, based on the understanding, and also memorize the process. Let me do it again. Convert a fraction to the equivalent percent. We use the numerator to divide by the denominator. We have a decimal, right? We're gonna make the decimal 100 times bigger, because later when we attach the percent sign, that percent sign will make the number 100 times smaller. So that's why we need to balance that out. To balance that out, we multiply the number by 100. Right? We have 37.5, and then attach the percent sign to cancel what we have just done, multiply by 100. And this percent value-wise is the same with 3/8. They are equal. Am I clear about that, guys? Would you like to try 1/40? Can you convert the fraction 1/40 to the equivalent percent? I just feel like it's supposed to be is equivalent percentage. When we talk about percent, we also always should have a number in front of it. Okay, convert 1/40 to the equivalent percentage. 1/40. Let's see, what do you have? Well, Jennifer, guys, you need to have a percentage. Yeah, very good. Jennifer fixed it right away. Yeah, 2.5%, right? Really 2.5%? 1 over 40. Yeah, it's about right. It's about right. If you don't have the percentage, you don't have the percent sign, that's totally different. Completely different story. All right, let's do it together. Numerator 1, denominator 40, divided by 40. On your calculator, you have this the decimal, right? And you're going to multiply that decimal by 100 because you know you're going to attach a percent sign behind 2.5. That would make the 2.5 go back, 100 times smaller, go back to the original value. So yes, the correct answer is 2.5%. 2.5%. Let me add a part C, okay? What if you have a 1 over 20? How do you convert the fraction 1 over 20 to its equivalent percent? Sometimes when the denominator of the fraction is special, how special? When the denominator of the fraction is a factor of 100, okay? When the denominator is just something extra, okay? When the denominator is a factor of 100 and convert the fraction to its equivalent percentage is going to be a lot simpler. We don't even have to go through the decimal. This is how do we do it, all right? 1 over 20, the denominator is 20. 20 is a factor of 100 because 20 goes into 100 5 times. 100 is 5 times bigger than 20, right? For that reason, we can do this. We're going to multiply both top and bottom by 5. Why do we do that? Because we want the denominator to be 100. Yeah, 20 to 100, all it takes is a factor 5. From 20 to 100, all it takes is a factor 5. So we multiply 20 by 5 to keep the fraction unchanged. We're going to do the same thing to the numerator. So multiply both top and bottom by 5. And we would have 5 over 100, right? Or 5 divided by 100. Remember, divided by 100 means a percent, right? So 5%. You see that? 5 out of 100. Yeah, every 100, 5. Yeah, for example, the tax is 5%. Means every or the sales tax 5%. Wow, I don't think any city has this low sales tax. Maybe some other place. Okay, our sales tax is a lot higher than this one. Just for example, 5%, 5 over 100 is the tax percent, tax rate. So that means that every time you purchase $100 worth products, not only you have to pay the seller, you have to pay the government $5. So 5 out of 100, right? The proportion. Every time you purchase $100 worth goods, you have to pay the government $5. So 5 per 100, 5 divided by 100, 5%. So this is just something extra. If you like it, will just make your job a lot easier, faster. If not, totally fine, because remember, I already showed you how do you convert a fraction to percent. 1 over 20, 1 divided by 20, you have decimal, multiply the decimal by 100, make the 100 times bigger, and then attach the percent sign to make it 100 times smaller, right? So 5%, same thing, 5%. Well, on this scientific calculator, it's interesting, I just found out. If I put a here, and I click this button, percent, hold on. If I put A here, oh, it doesn't work this way. 50%. Okay, it doesn't work this way. Never mind. So that's the first thing we learned today, right? Excuse me. Convert from a fraction to percent. What if we have decimal? How do we go from decimal to percent? And this is easy, right? Yeah. Firstly, you make the number 100 times bigger. Move the decimal point to the right twice. 0.47, make it 100 times bigger, you have 47. And then attach the percent sign to balance out, right? When you attach the percent sign, you make the number in front of it 100 times smaller. Same idea here. You move this twice to the right, you have 287, and then attach the percent sign. So balanced out, multiply 100 and divide by 100. Okay, you try part C. Please try part C. Don't forget the percent sign. Awesome, very good, perfect. Oh, that's a typo, I know. Right, Ashlyn? Yeah. Very good, perfect, awesome. Exactly. Very good. 0.3%. We move the decimal point to the right twice. 1, 2. So I have 0.3. And then attach the percent sign. That's it. I hope this practice. This one, go back. What if you are given a percentage and you need to convert the percentage to its equivalent decimal? Why would we do that? Because sometimes when we have an expression involving percentage, and we need to evaluate the expression, and we want to handle decimal. We don't want to, directly deal with the percentage. We want to deal with decimal. Okay, so this is not that difficult. In order to convert this percentage to its equivalent decimal, the answer will not have the percent sign anymore, right? So basically, we are going to get rid of the percent sign without changing the value of the expression. Again, what does a percent mean? Percent, percent, per means divided by, cent means 100, means divided by 100, right? Use your calculator. Yeah, you are allowed to use any calculator. Oops, no, I didn't mean to open this one. I mean, I mean the scientific calculator would be enough for this one. 19%, 19 per means divided by, cent means 100. Then the calculator tell you what is it, right? 0.19, 0.19. Also, if you do not want to use the calculator, there's even faster way to get it done. 19%, right? You know 19 divided by 100. So 19 actually is 19.0. When you need to write a check to somebody, 19, for example, you want to write a check with $19. You don't just write 19, right? You write 19.00, right? So 19 as a whole number can also be written as a decimal. It's 19.0. So this is where the decimal point is in a whole number. And you move the decimal point to the left twice, 0.19. That's it, right? Either way. So if I do part B, if I use the method 180, so this is decimal point, right? If I move the decimal point to the left twice, I have 1.8. So the answer is 1.8. Or I can try my calculator. Enter 180 in a calculator, 180. Percent, per divided by, cent, 100. Done. Same answer, right? Yeah. You can try both. Part C is challenging. But I'll let you give it a try. Half percent. Yeah, how do you handle half percent? Do not rush. Make sense. A lot of time we need to use the common sense. Too much. Charlie, 50%. What is 50%? 50% is half. If you have that 0.5 is also means half, but you're converting half percent. You're not converting half, you're converting half percent. Okay, so firstly, it's not very convenient with the fraction in front of percent, right? So you want to rewrite 1/2. Rewrite 1/2 as 0.5. Rewrite 1/2 as 0.5. I'm going to use the color scheme. I just rewrite 1/2 as 0.5. The percent sign is still here. And then I'm going to remove the percent sign. Now I have a half, I have a 0.5. Percent per divided by cent 100. That's the answer, guys, okay? 0.005 is the answer. 0.005. Half percent. You might need that in real life, half percent. So what is 50%? What is 50% mean? Let's think about a pizza, a pizza, very large pizza. You eat 50% of the pizza. 50% of the pizza is half of it. Okay, let me draw it. So this is the pizza. 50% of the pizza is half of it. Is a lot, okay? But a half percent, let me show you what is half percent. Half percent of the pizza. Firstly, you cut the pizza into 100 equal slices. I know it's difficult in theory. You're gonna cut a pizza into 100 equal slices. 100 equal slices. It's gonna take a while, you know. 100 equal slices. This is only 1, 2, 3, 4, 16. Yeah, so I'm gonna cut it very small, okay? Like 100 slices, 100 equal slices, and half percent is half of the slice. Let's suppose you cut the pizza into 100 equal slices, and half percent of the pizza is only half of your tiny slice. Does that make sense? Those two numbers definitely not equal. We are taking quantitative reasoning. We must have a correct sense, a good sense feeling about numbers, right? Those two numbers are very, very different, very different. 50% again, 50% is half the pizza. Half percent is when you divide the pizza into 100 equal slices, and you take one slice, that is 1%, and then you cut that one slice into half. You take half of it. That's how small half percent is. All right, half percent, very tiny, very tiny. I know this is challenging because, yeah, you know. So all you need to do is you rewrite half as 0.5%. Right, 0.5%, and then get rid of the percent by divide 0.5 by 100. All right, if you are clear about this problem right now, means you have a good sense about percent. Start to have a good sense about percentage. All right. Okay, so now we have talked about what is a percentage? Yeah, what is a percent? What is a percentage? And how do we convert between decimals, fractions, and a percent, right? And that's something very basic. And now we start to talk about the application of percentages in finance. We're going to talk about discount. We're going to talk about tax. We're going to talk about the misuse of a percentage in reality. Okay, let's get started. I mentioned discount problem, right? Oh, yeah, we can do discount problem first. Okay, this one, a gaming laptop with an original price $1,460 is on sale at 15% off. Okay, 15% off. You know, this is very interesting. I say this doesn't mean to confuse you. I'm just think about it. I want to mention is pretty interesting. In my country, if you go to a mall, you will not see 15% off. They don't do that. In the mall in China, they do 85%. Yeah, 85% of the original price. Instead of telling you 15% off, they just tell you right now the price is 85% of the original price. Isn't that interesting? We process the thing differently, right? Okay, this is the USA, so we're gonna do that. When you go to a mall, you see a product you want to buy is on sale. Let's say the laptop is on sale, 15% off. 15% off. Then that means compare with you purchase the laptop with the original price, you are going to save some money. And the money you save is called the discount amount. All right. So part A, what is the discount amount? Let me give you the formula. Discount amount. Again, we are learning quantitative reasoning. So the important thing is to make sense of the numbers, not just memorize a certain problem. Yeah, focus on understanding. Discount amount is equal to discount rate times original price. Okay? So think about the discount amount is the money you save compared to you buy the laptop with the original price, right? Yeah, how much you save? You save 15% of the original price. So you just need to multiply 15% by $1,460, right? Okay, so 15%, we just talk about percent. Percent is not convenient in operating expressions, so we want to convert 15% to the equivalent decimal and then do the operation. 15%, so divide 15 by 100, we have 0.15. Or you just move the 15, the decimal in 15 to the left twice, right? 0.15. Multiply 0.15 by 1,460. Let's see what we have. On your calculator, you can do this, right? You don't really have to manually calculate. For 15%, 15%, so 15% divided by 100. That's 15%. And then multiply that 15% by the original price of the laptop, $1,460. Ooh, you save $219. Okay? Yeah, suppose you buy the laptop with the original price, then you pay 1,460, but now you're gonna pay less. How much less? $219 less. 219. The unit is dollars, right? Because we're talking about money. So that's the discount amount. You don't have to memorize the formula, but you need to know how to calculate discount amount. If the product is 15% off, means you're going to save 15% of the original price, right? Yeah, then you just use the 15% to multiply by the original price. Then you have the money you save. And that money you save is called discount amount. All right? Of course, what you really care is how much you end up paying, right? Without talking about tax, you pay 219 less. So you're gonna subtract 219 from the original price, 1460. Let's see what we have. 1460 minus 219, 1241, 1241 dollars, right? So that's the new price. That's the laptop sale price. Does that make sense, guys? Pretty straightforward, right? Yeah. So earlier I mentioned in my country, we don't really care how much we save. When you go to a mall, let's say the same product, if the same product, same discount in China, in the mall, they're gonna have the sign, right? Say 55%. Because if you pay 15% less, you're gonna pay the other 85%, right? Yeah. How do I get the 85%? Because 15 and 85 add up 100. Use 100 to minus 15, we get the 85. So instead of thinking about how much money I save, I only care how much money I end up with paying, right? So 85%, I'm going to pay 85% of the original price. I'm going to pay 85% of the original price, 1,460. Let's use a calculator to figure out how much is that. I'm going to pay 85% of the original price. 85% per divided by cent 100. That's 85%. And then multiplied by $1,460, right? $1,241. So we don't really care how much we save. We know actually the promotion, those just discounts, just promotion to try to sell their inventory, right? They will still have a profit. Maybe they make less profit, but when more people buy the product, they actually end up with more profit. So we know it's just a strategy. It's just a strategy. What really matters to the customer is how much money they pay, right? What's the real sales price? That's it. That's about discount. That is interesting. Yeah, is very interesting. So the first time I came to, what, 15%? It really means 50% of the original? No, it just means 15% off. You pay 85% of the original, right? Okay. Yeah, sometimes the mall has like 30%, not 30% off, it's really 30% of the original price, even 10% of the original price. Okay. When Trump now start a tariff, it's just gonna have more products gonna have to sell in the country, inside the country. When you have more competition, the seller is gonna lower the price, right? Okay, so that's the first application, discount. Next application, tax. Here the tax refers to sales tax. We only talk about sales tax in this section. Next section, we're going to talk about income tax in detail. It's going to be very interesting. All right, look at this example. Suppose that the local sales tax rate is 7.5%, lower than Tulsa's sales tax rate, right? Higher than Miami's sales tax. Miami has 6%. I think Hawaii has lower, but it has other type of tax and make it actually higher. And then you purchase a mountain bike for $894. How much tax is paid? What is the mountain bike's total cost? All right, let's see this one. Earlier, the discount problem is a markdown problem. Earlier is a markdown problem, means you pay less than the original price. And here, the tax problem is a markup problem. You do not just pay the price of the product, you have to pay the government. You have to pay the government a certain amount of money. And here is 7.5% of the money. So you're going to pay 7.5% of the price of the bike. Yeah, it's 894. All right. Not only you have to pay the seller $894, you have to pay the government 7.5% off. OF in algebra means multiply. Yeah, those two you should take notes. OF means multiply. Per means divide by. We talk about per a lot today, right? Let's do the math using a calculator. 7.5%. So 7.5 per cent. Per means divide by. Cent means 100. That's how much is 7.5%. Okay. Multiplied by $894. So we have to pay the government $67.05. 6705. You pay the government $67.05. All right. So if you want the formula for tax, for tax amount is tax rate times the price of the item. Okay. If you want, it's good to know the formula, or you just use your sense, your understanding about what is, how much the tax in dollar. So I have to pay 7.5% of the worth of the product, right? So I multiply 7.5% by the item price. Either way. Part B, what is the mountain bike's total cost? So on your receipt, you go to amount to buy the mountain bike. On your receipt, you will not have just 894, right? And you would have more than that because you have tax. So you would have to add, this is a markup problem, right? Add the $67.05 on top of the price item, 894, price of the item. So you would have, we can use calculator. That's the tax amount. Tax amount plus $894, 961.05. 961.05. $961.05. Always like that. Some old town in the country, they have very high tax. Like where I live is small towns have very high tax. So if I go to Tulsa to buy something, I actually save a little bit of money because it has lower tax, sales tax rate. All right, does that make sense? This is a markup problem. So in part B, to know how much you end up with paying for the mountain bike, you add the tax amount on top of the mountain bike price. You pay more than the labeled price. It's different from discount. Discount problem, we have marked it down, right? You pay less than that. But when we talk about the discount problem, we didn't concern the tax. But in reality, even the item is on sale, you still have to pay tax. Okay, what is the book say? This country, Uncle Sam, death or tax or death. Those are the two things inevitable. What's the word? You cannot run away from, right? Death and tax. Death and tax. Okay, so that is sales tax problem, markup. Yes, that makes sense. Okay, thank you. We have two more participants. As I mentioned, I will not respond to emails requesting updating attendance. So when the class is ending, when we're getting closer to the end of the class, you have to remind me to fix your attendance, okay? Remind me like 2 minutes or 1 minute before 2:20. Let's go back to notes. Next, we are going to talk about percent increase and percent decrease. Percent increase and percent decrease. A lot of times, for example, you work with a company, they always have meetings and explain what's going on with the company, right? Like the sales this month compared with last month, how many percent up or how many percent down? That is talking about percent increase and percent decrease. Okay, so percent increase. So the tax and the discount problem we just covered. There are actually special cases of a percent increase and a percent decrease. So this is actually more general case. And what is a percent increase and what is a percent decrease? I'm going to explain with this example, okay? Percent part A, yeah, ignore part B now. Only look at the part A. I'm going to do this, then you don't confuse one with the other. Yeah, part A is percent increase. Find the percent increase. Okay, I'm gonna write a formula first, but you don't have to worry about that now. I'm gonna try to explain the idea, the concept, then you can understand what is percent increase and then remember the formula easily. Okay, percent increase is new value minus original value all over original value. So for example, last month you sold 6 cars, right? And this month you sold 10 cars. And what's the percent increase? Suppose you are a vehicle sales representative, right? So you want to know how much percent have has gone up, right? So here you are comparing with the last month. So you are always comparing the change with the original value. So your sales go from 6 to 10. 6 here is original. On your scratch paper, you need to write down original is 6. Yeah, on your scratch paper, you're going to write down original is 6 and your new is 10. Original last month 6. This month new 10, right? On your scratch paper, you should always do this. Trust me, without this, you're going to mess it up. So when you see a problem is about finding percent increase or percent decrease, do this. Write on your scratch paper, original is what, new is what, okay? And so from original to new, how much your sale has increased? You have sold 4 more, right? So the difference is 4. You have the total increase. The total increase is 4. And you are going to compare the increased amount with the original amount. That gives you percent increase. All right, does that make sense? The percent increase tells you compare with original how much the increase is. Okay, compare with the original how much the increase is. From 6 to 10, the number has gone up by 4, and you're gonna compare that 4 with the original, not this month, last month. And let's see, how do we write that as a percentage? That's a fraction, right? Divide 4 by 6, and then multiply by 100, right? And then attach the percent sign. I'm going to round it up to the nearest integer, so 67%. 67%. Not exactly, so approximately equal to. And the 67% is the percent increase. I want to spend more time on this part because in previous semesters, I think I was very clear, but students end up with did not do well on the test. Or they later ask me, I don't know how to do this problem, percent increase, percent decrease. You're gonna understand the concept. Percent increase is a way to compare the change with the original amount. From 6 to 10, the change is 4. You compare that with the original, right? Last month you sold 6 cars. This month you sold 10 cars. So you sold 4 more cars. The change is 4. Change is 4. And you want to compare the 4 with the original. So your sales has gone up by 67%. And you need to understand that because when you look at the internet or hear radio or TV, a lot of times they are talking about this, especially in finance. If the price of the stock has gone up, how many percent, or how has gone down, how many percent, or the sales has, or the inflation has whatever, right? So it's very, very important. If you are in business major, even in health, and you probably encounter some information that have compared the weight of the patient with the patient's weight like last month, or the blood pressure, those change. Yeah, whatever you do, your major in, if your things always have change, right? You want to compare the change with the original value. And this is the formula. I recommend that you try to memorize the formula, even I know it's difficult for some reason. You use new value minus the original value, okay? Use the new value minus the original value, because that would give you how much the number has increased, and use that change to divide by original. Very, very important. Always divided by the original. Always divided by original, okay? All right, now let me give you a problem. Exercise. Let's say last semester you took this class, you got a 65%, right? You get a 65 point score. And this semester you want to get a 90, right? Yeah. Last semester, the same class, you got a 65. This semester you get a 90. I hope you get a 90. And what's the percent increase? Knowing percent increase is a percentage, you need to have the percent sign behind the number. Okay, you have 2 minutes. Last semester you have 65, and this semester you have 90. Find the percent increase. Round it to the nearest integer in a percent. Yes, very good. Perfect. Awesome, guys. You guys are awesome. Very good. Exactly. Even a rounding is very correct. Is correct. Is correct. So I give you 65 to 90, right? From 65 to 90, we use 90 to divide it by 65. So that's how much it has gone up, 25. And compare that with the original 65. And then it's decimal, right? But you know our answer is supposed to be a percent. So you multiply by 100. Round it to the nearest integer. So we're gonna cut it off, get rid of them. So 38%. Because this 4 is less than 5. 38%. Awesome. Very good. Very good. So that is a percent increase. Percent increase. Now let's look at the part B. If 10 is decreased to 6, find the percent decrease. Find the percent decrease. Percent decrease. Formula. Oh, actually, I have to fix this. 100, multiply 100, and then attach percent sign, right? Because the result is supposed to be a percent. So percent decrease is you use the original value minus the new value, and also divide by original. So always divide by original, and then multiply by 100, and attach the percent sign. Okay. So let's say last month you sold 10 houses. This month you only sold 6 houses, and you want to know, or the company, right? The company last month sold 10 houses, this month only sold 6 houses. So the boss in the meeting show you the percentage, how many percent down. And how do you understand that? Compare with original 10, right? Last month 10. From 10 to 6, the change is 4. The change, you lost the 4 houses profit, right? Yeah, the change is 4, negative 4 actually. So 4 less, 10 minus 6 is 4. And then use 4 to divide by original, knowing this time the original is not 6. The original is 10. Very, very important. Very, very important. When you need to find the percent increase or percent decrease, always divide the change by the original. So here the change is 4, gone down 4, and divide by original. And then, you know, this is the case that the denominator is a factor of 100. So multiply by 10, 10 multiplied by 10. So I have 100 on the bottom, I have 40 on the top. So 40%. So the percent decrease is 40%. Percent decrease is 40%. Original 10, new 6. 10 minus 6 is 4. That's how much the amount has decreased, right? Decreased by 4. But as a percentage, we compare that 4 with the original. That is 40%. How is it not the same for the increase? Yeah, that's a good question. The increase time is the original is 6. Yeah. You always have to do this. Original in B, part B, original is 10. The new value is 6. They put this together to confuse you. In part A, original value is 6, new value is 10. You are comparing the change, which is 4, with the original, with last month's sale, 6, and get a percentage. But part B, the original is 10. It says if 10 is decreased to 6. So the original value is 10. The new value is 6. That's why we are talking about percent decrease, right? From 10 to 6. From 10 to 6. So decreasing. So the original is 10. The new value is 6. So from 10 to 6, gone down 4. And divide that change by original 10. You are always comparing with the original. Does that help, Alex? Oh. So now you know when you look at the internet or hearing the finance news talking about it's gone down how many percent, you know, okay, that percentage is use the change to compare with the original. I hope those numbers make more sense to you. You're welcome. Hope I'm clear enough. If not, feel free to let me know. Appreciate that. Try this one. Percent decrease, right? Yeah, try this example. This is to find the percent decrease. Do not forget what I told you on your scratch paper to write original and new, and then apply the formula. Try to memorize the formula right now. Understand and memorize the formula right now. A pair of jeans regularly sells for $135 and is on sale for $60.75. Find the percent decrease. Find the percent decrease. Is to find the percent decrease. On your scratch paper, you need to do this. Original. Trust me, if you don't do this, you mess it up. Write down original and write down new. You must divide it by original. Let's see what's your answer. What's the percent increase is $55? Yeah, Ashlyn is correct. Ashlyn, 55%. Your goal is to find the percent decrease. Your result is supposed to be a percentage with a percent sign in it. The number is correct, Jennifer and Ashlyn. Oh, Ashlyn was correct. Yeah, 55. No dollar. Percentage doesn't have a unit. Percentage doesn't have a unit. Okay. Yeah, no dollar. It's just a percentage. It does not have a unit. All right, so let's do that together. Very, very important. Write on your scratch paper original and new. Original 135, new 60.75. So it's on sale, so the new price is lower, right? That's why since the price gone down, they want to know the percent decrease. Okay. What's the change in the price? Use the original price, the bigger price minus the smaller price, 60.75, right? And 74.25. Use that. That's the change. That's the price has gone down that much. That's in dollar, by the way. That is in dollar, by the way. And then you're gonna divide that, divide that by original. Compare that dollars by the original 135.55, right? And that's a decimal. You want to convert that decimal to percent. Multiply by 155%. So let me show you why we do not have dollar here. So you have $135 minus $60.75 over $135, right? So the change is, what's the change here? 135 divided minus 60.75, 74.25, $74.75, right? The price has gone down $74.75. I agree, that is in dollars. But you are looking for the percent decrease. So you're going to compare that amount of dollars with the original amount of dollars. So the dollar cancel dollar. Remember the property of fraction? Yeah, the dollar cancel dollar. So you do not have unit. You do not have unit. All right. You have 0.55, and that is 55%. So it means the product is on sale with 55% off. This percent decrease actually is your discount rate. Percent decrease. Is that clear, everybody? Okay. I need to find a problem in Pearson. Yeah, I need to find a problem in Pearson because that problem, there are always students asked. There were always students asking about that problem. A.1. Let's see which problem. Is a bar graph. Yeah, the problem is a bar graph, probably later. $16, $17, $18, $20, $19, $21. Yeah, this one, guys. Find the percent, the increase. Okay. There's always students ask about this. And very likely you have this problem on the test. Let's read the problem. The bar graph shows that life expectancy, the number of years newborns are expected to live in a particular region, has increased dramatically since ancient times. Find the percent increase. This is important. Our goal, find the percent increase in average life expectancy of the region from, this is also important, from the Stone Age to 2016. Stone Age, this one Stone Age, 2016 is here, okay? So we are looking for percent increase. Remember, I have emphasized many times on your scratch paper, please write down original and new. Okay, we are looking for percent increase because it's gone up, right? Increasing. So write down your original and new. Original life expectancy is 26-year-old. New, by 2016, the average life expectancy is 72 years old, right? Yeah, write this down, original and new. Yeah, let's see how much it has gone up. From 26 to 72, so you have 72 minus 26. Oh, 46. It has gone up 46, right? And your answer is not 46. You are looking for percent increase. You are comparing this increase amount with what? Original. Compare with the original. So you're going to divide by 26, divide by original. Okay? And use that to divide by 26, original. And then multiply by 100. And how do we, let me see, how do we round it? It says, okay, very important. Round to the nearest integer. Okay, round to the nearest integer. So we round it to the, so 9 is bigger than 5, right? So 177. So 177%. That's the percent increase. All right. This question a lot of every semester. So the formula, if you like to use a formula, percent increase is new value is original value. New value is increase. New value minus original over original. Okay. New value is 72 years old. Original is 26-year-old. And that's how much has gone up. 646. Use that to divide by original because you're comparing with the original, all right? And multiply 100 and attach the percent sign. And then round it. Very, very important. This chapter, in the past semesters, students did not do well. But they could have done well. Only because they don't listen to me. I do not understand. They did not listen to me. Because I repeatedly emphasizing. Read the information in the parentheses. Those print are very important. The rounding is very, very important in this chapter. It's very important to your exam too. A lot of students mess up the second exam because they don't pay attention to the rounding instruction. They don't care. They just round whatever they want. No, you cannot do that. They told you here in the parentheses, they have the print. Round to the nearest integer as needed. So the number you enter must be an integer. Okay, round it up because the digit is bigger than 5. So round it up. Is that clear, everybody? Is this problem clear enough? Yeah, the percent increase, percent decrease could be over 100%. That's totally fine, right? Because the age has gone up so much, even twice bigger than original, right? Okay, very good. The last topic we have like 12 minutes is how in reality how percentage sometimes are used incorrectly So here, let's look at this example. We might only have time to talk about this example. A politician states, if you elect me to office, I promise to cut your taxes for each of my first 3 years in office by 10% each year, for a total reduction of 30%. Evaluate the accuracy of the politician's statement. Okay. Sometimes it's not they don't know. Sometimes they just purposely overestimate. Okay, let's see. So seems okay, right? Each year cut 10% and then you end up with cut 30% is actually not that case. It's actually not that case. We can make a table if you like. Year, okay. Let's do year 0, year 1, year 2, year 3. How about that? Okay. So that is the original tax rate and the new tax rate. And this is change. Let me see how we organize this. We can do, okay, how about let's just do tax. Yeah, new tax and change. So originally, let's say you pay $100, right? Yeah, without the politician, before the politician took the office, you need to pay, you're supposed to be $100 tax originally. And of course, those are not new tax, right? The year 0 is just year originally is $100. So let's say now the politician took the place. By the end of the first year, he promised to cut 10%, right? Okay. So yeah, original, you know what, actually we do not need this. We do not need this row. We're gonna do year 1. Originally, you're supposed to pay $100. So by the end of year 1, since the tax is cut by 10% off, right? So you save $10, right? So how much is your new tax, guys? Tax cut 10%. Okay, 10% of $100 isn't that $10? So mark down. So you minus $10 from the $100. Your new tax is $90. Are you guys with me? Your new tax is $90. 10% off. You see that as a discount. How about that? See that as discount. Okay. See that as discount. So now you pay $90, all right? So the change is we're gonna do that later. So so the year 2, the beginning of year 2, your new tax is gonna be $90, right? But over the second year, the politician gonna cut 10% off again, right? But that 10% is applied to your 90% tax from last year, 90%. And 10%, sorry, $90. 10% of $90 is just $9, right? So second year, you only saved $9. Second year, you only saved $9. Use 90 to minus 9. You have 81. All right? So your new tax, the end of the year 2 is $81. So that's the beginning, that's the tax you pay the beginning of year 3, right? The original, consider year 3, the original tax from the previous year is $81. And June year 3, cut another 10%, but that 10% is not applied to 100, applied to $81, right? How much is 10% of $81? $8.10, right? $8.10. And you save that much, save less and less. So you're gonna use 81 to minus 8.1. How much is that? 81 minus 8.1, that's 9 to 72.9. 72.9. Yep. 81 minus 81. Oh, hold on. 81 minus 8.1. 72.9. Yeah, that's correct. So, after 3 years, okay? After 3 years. If we now look at the 3 years as one whole time period, the original tax you need to pay is 100. The new tax you end up paying is 72.9. Let's see what is the percent increase. All right. Let's see how much percent decrease. My bad. Percent decrease. You pay less tax. So you pay this much less, right? Originally you should pay. You're supposed to be 100. Now you only need to pay 72.9. That's how much is it? 27.1. I'm just double check. 27. 100 minus 100. Oops. 100 minus 72.9. Yeah, 27.1. 27.1 divided by what? Original 100. So it's 27.1%. The percent decrease, the discount rate the politician promised is a 30%, right? So after 3 years, you actually get a 30% down. It's not accurate. It's actually 27.1% down. Does that make sense, everybody? Yeah, my table a little bit messy. So you should think through. We don't really need the last column. We should this table would be enough. Like 1, 2, 3, 4, 4 rows, 3 columns would be enough. Okay, very good. Let's see the last problem. Yeah, this is the last one. The price of a color printer is reduced by 30% of its original price. When it still doesn't sell, the price is reduced by 20% of the reduced price. The salesperson informs you that there has been a total reduction 50%. Is the salesperson using percentages properly? If not, what is the actual percent? We have 5 minutes. Would you like to try this problem? This actually could just happen in reality. Now you have the critical thinking. You have a sharp eyes, right? You can tell. If somebody tell you this, you're gonna know, oh, he is trying to overestimating the reduction. It's not that much, actually. Okay? Because when we talk about, yeah, here I need to emphasize. When we talk about percent, a number followed with percent is meaningless if we only talk about how many percent. Whenever we talk about percent, there's a package go with it. 20% of what? Okay, whenever you hear 30%, 50%, 20%, 20% of what? The percentage by itself means nothing. It needs to have a package go with it. Then you can understand, oh, what's that? That person means that. 20% of what? You need to understand that, all right? So here we have 30%, 20%. 30% of what? 20% of what? Yeah, work on the problem. For convenience, we can say the price was $100. It didn't given, right? But doesn't matter. We can Just assume the printer was $100. You will find out the result has nothing to do with the original price. I can't hear you. Oh, I wasn't talking. Okay. Yeah, I give you some time that you can work on yourself. At the same time, I was writing my answers. What do you have, guys? Yeah, since we only have we run out of time, so I'm gonna quickly explain what's going on. All right. Suppose the original price is $100, 30% down, so the new price is $70, right? Very convenient, yeah. And now if you still not sell, another 20% down. But that 20% is going to apply on 70%, not 100%. Okay, this 20% is apply on 70%. And 20% of on $70, sorry. 20% of $70 is only $14. So after you reduce the $14, you have $56. So after twice reduction, the new price is $56. Original price is 100. We plug in to the percent decrease formula, we got a 44%, not 50%. Okay, it's 44%. Did you see it, guys? Okay, anybody was late, please let me know. Yeah, he lied. Yeah, he overestimated. Yeah, maybe it's his strategy. Now you have a sharp mind. You have a critical thinking. That's not true. At least not accurate, right? Uh, who? This is still 16. Actually, I fixed already, right? I fixed. Oh, levy. Oh, yeah. So just levy. I'm going to fix levy attendance. Uh, yeah, try to join a meeting on time. As you can see, this is really not very convenient for me to go back and forth. All right, guys, I'll see you on Wednesday. Essential class, I'll see you at 2:30 in another class course shop. You're welcome. Bye bye, guys.